it looking ugly, because a lot of our life depends on identifying things by shades of color. So, when UV happens, the color changes. Compatible with you shall know which heat up to 220, such as so on and so on like that. Next one is, you see the other one. See this here, maybe a little bit of reality will this thing. This is the support material, then there is a base material, and this is the usual thing which people use when they print with maker bot. What is this? This is the PLA material. PLA is polylactic acid stuff made from biological materials like cornstarch and sugarcane, similar to the material used in degradable plastic packaging, and melts at between 180 and 200. Compared to that, it is 100 degrees lower, depending on other materials that are added for color and texture. Is a tough resilient material with a matte opaque quality. See that issue is, instead of it being reflective, if it is matte, any matte surface hides defects. Any reflective surface highlights the defects. So, any small changes in variation, small changes in thickness, or in case there is any shrinkage or warpage and all, it will be highly visible in the case the material is reflective. And you see here, it is not as tolerant of heat as ABS or PLA above 60, and it is not water or chemical resistant. There is a slight smell when it is heated and so on. It is preferred for low cost 3D printers because it is easier to print than with ABS, as it is stickier. It will stick well to a base which is covered in white glue or blue painter's tape, which means that heated print bed is not needed. Material is also biodegradable like other so on and all that. Often is not, it is food safe and somewhat brittle, making prints prone to shattering under stress. So, usually a combination of this PLA which is used as a support material, which one particular what you call combination, where it very easily dissolves in water, and the main object at the top is the main build material, which is tough and made with other options. So, the advantage is, after this job is made, if you just put it in a water bath at a higher temperature which is between this softening and this what you call the highest what you call softening temperature, and if you leave it soaked for 24 hours, it is easy, you can snap off the parts. See this, this is the second preferred material. Now, they have given everything: prints degrade, rougher texture than ABS, or general printing and painted miniatures. Next we come to PVA. See this, polyvinyl alcohol material is a new class of 3D printing materials that are used to make supports that hold 3D prints in place. A synthetic polymer PVA is water soluble. While I told you the one there saying that PLA is used, right now everything is slowly being changed to this PVA. The advantage being, it can be used in a standard printer extruder to form parts that support other objects, and after this thing is over, you put it in water and soak it. PVA parts will dissolve, leaving the rest of the insoluble print behind. This makes it easier to print complex models that require supports, or even models that include moving parts. If you use water to dissolve, you will need to properly dispose of, as the sticky residue can clog drains and so on. So, we have all this stuff which is these three are the very common things which is used there. And if you remember, I showed you those gears. Now, I have also shown you these rotor blades of the fan. These things will what do you call are made with a combination of those materials. Next, the true engineering plastic is probably nylon. So, we have a what you call several of the parts which you see actually are probably all made with these things. They are strong and they have a way of, the one you see there is a clip. It is probably a clip to hold something to the other, and similarly these are all some wells, micro wells, and then I am not able to identify the parts. The name can be for any number of synthetic polymers originally as replacement for silk. It is a tough material that has very high tensile strength. It can hold a weight without breaking, melts at about 250 degrees and is non-toxic. Use as a relatively 3D printing material is new, but the material is becoming popular. Prints produce tough, resistant to damage. And I say cheap, cheap is not a proper semantic word, it is inexpensive because nylon is widely used in other industries, not damaged by most chemicals. Nylon does require high temperatures, hotter than many extruders, and it is harder to get to stick to the print bed than with ABS. Generally requires both a heated print bed and white glue to stick while printing. Inexpensive, in that what they have called cheap there, now he has made it inexpensive here. And utensils that touch food, plant pots that fill with water and all that, these are things. Next we come to high density polyethylene. So, what exactly is HDPE? This is the same plastic bucket, wrongly called high impact polystyrene, but high density polyethylene is used in pipes and recyclable packaging such as plastic bottles and packages, and all our buckets come from that. The advantage being that it is widely available, and the granules and filaments and all that are very easily available. So, slowly HDPE is getting to be used in what you call often used as comparable printers turn out lighter and stronger than with ABS and HB, and HB does require higher temperatures to print though, and can release unpleasant fumes. The temperature is set too high. It is resistant to most chemicals. You can dissolve with limonene and so on and so on. A huge this thing. It can also be used for a support material for the 3D prints made with other materials. Supports can be dissolved by immersing the thing in the appropriate solvent and will not affect materials. So, up to that point what we see there is the usual opaque commonly needed prints. And now you see the next item, you see here PETT, polyethylene terephthalate. What looks like actually a missile or something is probably just a model, or it is a toy or something like that. It has a very interesting appearance. It is a chemical made up of or what I call a trade name is called tea glass, similar to polyester used to make clothes. It melts at about 230 degrees, but cools into a rigid solid that resembles glass. It can be dyed while still retaining the glass like qualities. It is available in multiple colors. Tea glass is approved for food use, so you can use it to make dishes, cups and the like. For 3D printing, tea glass can be printed onto a print bed heated to about 70 degrees centigrade. Why this heating is required is otherwise things solidify quickly, and once they get stuck to the base, it is not easy to remove them, it sort of sets very well. So, if it is preheated, first of all distortion is not there, because it's sudden change of temperature right from 230 degrees softening and to room temperature, which could be 25 degrees, gives a problem. But if you keep it above 70 degrees, the printing and distortion is avoided, and overall the one is the energy required for the printing, and secondly stability of the parts is assured. So, we have here It is mainly sold something, a company which introduced the material. Tea glass itself is strong and resilient. It has to be printed slowly to make sure layers adhere properly. Printing with typically much slower than with other things. Clear material with a glass like look. Requires heated print bed, slow to print, used for things which are there. Next we come to so many of the new things. A wood filament. I have never seen it myself. Okay, I have not seen it myself, but I expect that it is a combination of materials. These filaments are not made out of wood, but instead contain very fine wood particles combined with this polylactic acid and a polymer that binds them together. When printed and polished, the finished material can look like wood. Versions are available for many different type of wood, from bamboo to ebony and mahogany. Some of these filaments allow you to change the color of the printed material by varying the temperature. So, you see here this looks like a case, I think, no, iPhone case that was 3D printed to just a novelty item, but eventually all these things in the long run will probably replace several of things which typically we are all used to wood because it feels warm to the touch. Even plastic has a slightly higher conductivity than wood. Wood, because of this texture and the thing, it feels warm, and we have got used to that, what you call, anything which has that look already is acceptable more. In fact, a lot of the outdoor stuff we see is probably inside there is some other material. It could be aluminum, it could be something else, and it is covered with a vinyl sticker and it just looks like wood. So, several of these even electronic boxes and all which have a wood covering, and best example is consoles for cars. If you see the console and the fascia of a car, the dashboard, the cheap ones are just printed with a wood pattern on good old plastic. Making those things out of this is very, very easy. So, if you want to try a new gadget, it could be a what you call a map maker, or it could be, I do not know, something which is very, very dangerous, a texter, anything which you want to do or a GPS tracker or a child alarm or something it will be much more acceptable if it matches with the remaining thing, or it contrasts by showing quality. And in all such special applications, invariably these wood items are kept. Now, if you go to it, these materials are printed in the same way as PLA with similar extruder thing and so on. So, wood like finish, but only problem is finicky to print with, requires sanding or other treatments to get the final desired look. So, more it is costly, the more it is attractive. Now, from here onwards honestly I have never seen a metal printed item except by the manufacturer, and we have a defense what you call huge defense establishment here. Most of our defense establishments, at least the sellers claim they use the full metal this thing. So, we have something here, you read it to yourself at the bottom. In this only the look is metallic, it looks like gold, it may or may not be there. So, maybe you can make a what you call 9.999 gold brick which is having a core which is probably made out of lead or even mild steel, and you insert it inside, and for good effect nobody will believe it. So, you can at least show it to your friend saying you are rich. That includes steel, brass, bronze and copper particles to create the look and feel of them respective material. Addition of the metal does change how they print, so experimentation is required. So, this being in the creative and early stages, you need to do, I will not call it trial and error, you need to specifically try your particular design. It is not like a routine, the usual ABS and PLA materials which or HDPE materials which are routinely supplied by the manufacturers. Now, if you go down further, we have this carbon fiber mix. You see here this beautiful car detailing, everything here is made with carbon fibers. RC with non-electronic parts are printed with carbon fiber. The exact stuff which I showed you the other day, I showed you a small box, that whole box was printed with carbon fiber what do you call plastic, because we have an advantage, we wanted a different purpose for it, saying it should look as if it is losing heat, hence the color, which is actually incidentally does not take anything, and we did not want it to look like a cheap plastic. Look at it, it looks like. Now you see here this whole thing it's of course assembled, it is not just printed, and I do not know, maybe tires will come on top of it. Carbon fiber filaments uses nylon, or this one from this thing uses PLA, combine carbon fiber and the filament material to give you some of the advantages of this new material: rigidity, strength and low weight. They should be used with caution. Carbon fiber is a very abrasive material that can wear away the hot end of the extruder. You need to get a reinforced extruder or keep replacing. So, we have this the what do you call, so many of these printers which use it, expensive but useful. Now, we come to the much more interesting and other thing, saying so far we have been talking about materials which are intended to be rigid. Is it just the materials just are intended to be rigid, or they are actually rigid? And when you want to make something flexible, as in an elastic band, it could be a hair scrunch, or it could be, in this case something like, sir, can you show me this? I am sure several of you probably have variants of these activity trackers, and you can easily print any of these things using any plastic. But if you want the type of flexibility, of course this one is a what do you call mesh, is a pakka stainless steel mesh. It has been woven and it has all the novelty, but you see at one end part, you see here has a strict small detailing. There is a groove, there is a magnet inside, there is a gasket all around like that. It goes and sticks here. Parts like this require a little bit of, on one side rigidity, on one side flexibility. So, in this case it is made out of a magnet, support material, and then a rubber. These things can probably be easily replaced by a flexible material that is shown here. So, if you just read it along, while all 3D printing materials strive for rigidity, creating prints that are strong, that is not always what you need. Flexible filaments like all these flex produce rubber like prints that can use to make things like phone covers, flexible joints and wearable prints. So, I am sure a lot of you have seen this, is it not? And lot of gag prints are there. So, there is one print I have seen which is my favorite at the back. It looks like a old Rolleicord camera. Okay, if you are holding it, people will think it is a Rolleicord camera, and it has even etching things on it. It looks like there is actually a lens here and all that, and then that is my son, he looks up and he will make it think, come on, look, and then he clicks it, and you have what do you call a cover which looks exactly like a Rolleicord camera, and then you have it with everything else. I will just try, kindly just be a little patient, and I will see whether I can get it. These are all retro brown leather vintage camera case. Seen that? No, there is not a print like this. This one is a Rolleicord print. This is, it is just a cover which is printed to make look like something, and then Frank and Heidecker lenses. all this, the whole thing is printed on a 3D printer, and you can just push it on your camera, and then your camera your normal Android camera looks as if it is a full fledged old vintage camera, and these things can easily be printed using the material which I was showing you, that is flexible material. And if you can now combine it with other things, including a lens, maybe a real lens, you can get the lens from a VR kit. So, you have the VR kit, you have the lenses, maybe if you make a groove and fit the lenses and all inside, you will have something which actually looks like a beautiful old Zeiss or the other Schneider lenses, which will be a beauty, absolutely beauty for you. This is where the flexible materials make a lot of impact, and you see that if you make something hard, it does not necessarily protect your thing inside. Optimum amount of crushing and resistance should be there. There is resistance and optimum amount will absorb the shock. So, things which have corners and all that are best printed using all this. So, you can here phone covers I showed you, flexible joints and variable prints. This flexibility also poses a small problem. FDM printers work by pushing the filament into the heated extruder where it melts. You can't do that as easily if the material is flexible. It would just block up the print head. So, most printers will require a modification to use this flexible filaments. 3D printer makers like so on and so on offer a replacement print head called the flexi extruder that is designed to this thing. Other manufacturers call semi flexible filaments like MakerBot's flexible and so on and all that. These are not as rubber like as the ones, but still provide some flexibility. For instance, becomes flexible when you put it in hot water, allowing you to reshape, squish a print into a tight fitting spot before the material cools and becomes rigid again. Now, you see the other things. There are not that easy, there is not as easy to print as you would print this thing, and as they make you believe in the popular press that you can print anything at home. You print a gun at home and I do not know whom you would like to shoot the shooter. We are not violent people, but we would like to defend ourselves like that. In case somebody is ready to shoot, at least incapacitate them and prevent them, but the reality is not that easy. Now, you come to which is something which is my favorite saying, can we make conductive filaments? This in our electronics we have an advantage and a disadvantage also. One of them is we need connections, we need both conduction and we need insulation. And conduction, you will be surprised even if you take most of our LCD prints and all that, it is a transparent material, glass or something, and there are conductors printed on it. If you print a very fine I do not know, gold or some other materials thin enough and make it into a matrix, eye cannot detect, but that can be used to apply a voltage. It can't take a current, but a voltage can be applied. So, now these conductive filaments, they have modified some of the properties. If you see my what you call that presentation, you see there. Please show this, sir. Blackmagic 3D that combine PLA with graphene, a form of carbon that conducts electricity. This means that you can print electric circuits directly without needing to add wires. This can be great for things like touch buttons, wearable electronics or styluses that conduct electricity. These materials also require care when printing, as the layers of the print do not stick to each other as well as normal PLA. The prints tend to be brittle and bending them can break the conductive graphene, so that they no longer conduct electricity. These are best used alongside normal PLA filament, and you would print a PLA case around the parts that conduct electricity to protect and give it more strength. So, in principle, a whole printed wiring board can probably be made as part of the product what you require. So, if you see I have this fan, everything is fine except inside this ribbon cable I still have copper, as copper is a must, because something of the order of nearly 1 amp has to pass through this. Imagine, and to support this, again we end up with this, 3 of these supports are normal and one of the support is wider than the other. So, a lot of circus is required for doing it. Imagine one day if we were to make this out of conductive filament, we can probably use, we have 4 supports, 2 of the supports can probably have a what you call one polarity, 2 of the other supports can have other polarity, and like I will not have this wire sticking there. I can probably plug in the whole fan having a plus and a minus here and a plus and a minus here. If I plug it in appropriately, nicely the fan will work, and look mum, no wires, I will be able to work well without wires. Eventually I may have fully conductive materials like this, by which life will be easy, but right now it is not at this stage. Right now at best these parts which require a little bit of physical structure continue to be in this, and the outside thing can be made flexible, but still there is copper inside. Eventually when only simple voltage driven with very little current is required, as in this case typically, we will eventually probably go for those things, which is I feel a very good thing. Now if you kindly look at this again, they are best used so on in the parts that conduct electricity, protected and give it more strength. So, we have come almost to the end of it. Now if you go to several what you call websites, you have various advantages, disadvantages of all these materials. You see here this particular thing gives you what all that has given, okay, saying we have polyamide nylon, white, strong and flexible, strong and flexible plastic. So, he has given examples here, seen here. Again once again we have a beautiful case, mobile phone case, and then we have a printer thing. Then he has given all the properties, minimum wall thickness, details and structures, and the price. So, if you go everywhere, next we have ABS, normal home printers, they come with these things. See here, details and texture are poor, price is okay, and then 1 mm, and then it is strong and flexible. So, anything you would like to print, probably you use these things. Next we come to the word resin is used. I am not clear what exactly he is talking about. Transparent white detail resin, high detail, printable resin, rigid and bit delicate. So, resin is generally used to what you call describe anything which does not have a sharp cut off point, unlike metals or even all other liquids, ice and all that. No, ice exactly melts at 0, and if you take any metal, they all at a defined temperature, 800 degrees, few degrees below its metal, a few degrees above it will come into pouring consistency. Unlike that, the resin has wide this thing, at about it will start softening around maybe 130, 140 degrees, and it does not melt at all. That from 140 to around 200, 250 degrees, still it will become sticky and stringy and so on, a little like some of our food materials we see. So, calling it resin, I am not very what you call comfortable with it, because all plastics are resinous plastics only.